Dear friends, welcome to my channels. Today's discussion is duality theorem. Duality, duality theorem. So friends, now let's start to discuss weak duality theorem. If x0 be any feasible solution to the primal and maximize zx is equal to 6cx subject to ax less than equals to b, and w0 be any feasible solution to its dual problem, minimize zw equals to b dash w subject to a dash w less than equals to c dash, and w less than equals to 0, then cx0 less than equals to b dash w0. There are three types of primal dual problems. Three types of primal dual problems. Symmetric primal dual problems. Here all constraints of the both primal and dual problems are in equation. Must remember friends this topic in equation, and the variables are non-negative. Unsymmetric primal dual problems. Here all constants of primal are equations and all primal variable non-negative. So unsymmetric is equation and symmetric primal dual problem is inequation. So friends, unsymmetric primal dual problems and symmetric primal dual problems, and primal variable are non-negative. And mixed type problems. Here some constants of primal are equations and some variables are unrestricted. Standard form of primal. LPP is said to be in standard form if all constants involve the form if problem of maximization. So friends, greater than this symbol is less than equals to, then problem of maximization, then we can see less than equals to this symbol, and all constants involve the sign greater than equals to in a problem of minimization. Hence we will solve another problem. Minimization z equals to 7x1 plus 5x2 subject to 3x1 plus 2x2 greater than equals to 20 and 4x1 plus 3x2 greater than equals to 30. I have already told that when is minimization, then it is greater than equals to in my class. So this is the greater than equals to. So whatever you see that corresponding problem, I can write in dual form. Problem is given minimize. In here I can write z equals to cx, min z equals to cx. C is equal to in here 7 5 and x equals to x1 x2. This is not dual, it is primal form. Primal, we can write it is primal. So this is mean Z, and matrix A equals to 3 2 4 3. This is my matrix. This is my matrix, and B equals to 20 and 30. So friends, C equals to 7,5. So I can write it into dual form. So it is maximize Z. As it is problem is minimize, so I can write it as a maximize. Maximize Z equals to B dash into W, where W equals to W1 and W2. So B dash equals to, I can write 20 W1 plus 30 W2. Okay, and subject to equals to A dash W equals to C. Sorry, not equals to, less than equals to C, because it is greater than, it is less than. So A dash equals to 3 2, A dash equals to 3 2 3 4 3 2 and 4 3. So 3 4 2 3 into W1 W2 less than equals to C, means in here 7 5, and after that I can write 3 W1 plus 4 W2 less than equals to 7, and 2 W1 plus 3 W2 less than equals to 5. So friends, this is my subject 2. I hope I can clear this concept. So next video is find out the dual of the problem maximize Z2 equals to 2x1 plus 3x2 plus minus 4x3, subject to 3x1 plus x2 plus x3 less than equals to 2, and 4x1 plus 3x3 is equal less than equals to 4, and x1 minus 5x2 plus x3 equals to 5. x1 less than equals to 0, x2 less than equals to 0, and x3 is unrestricted in sign. So friends, answer. So friends, x3, I can write it x3 equals to x3 dash minus x3 double dash, and maximize Z equals to 2x1 plus 3x2 minus 4 x3 dash minus x3 double dash. So subject 2 can be written as it is unrestricted. Must remember x3 is unrestricted, that's why I write this way. Now subject 2 can be written this way: 3x1 plus x2 plus x3 dash minus x3 double dash less than equals to 2, and 4x1 minus 3 into x3 dash minus x3 double dash less than equals to 4 minus 4, because I need it is the greater than equals to, but I have to do less than equals to, as the problem is maximize. In case of maximization, problem should be this way. -4, and after that I can write this way: x1 minus 5x2 plus x3 dash minus x3 double dash less than equals to 5, and minus x1 minus 5x2 minus plus 5x2 minus x3 dash minus x3 double dash less than equals to -5. Because friends, you see that it is equation. This type of problem is called mixed symmetric dual. So friends, it is equals to can be written less than equals to 5 or greater than equals to 5. It can be written. That's why I have written this way: x1 minus plus 5x2 x3 minus x3 double dash. Now I convert it into dual. So dual problem, in here our a is considered as 3 4 1 minus 1 1 minus 3 minus 5 5, sorry, it is not minus 3, 1, it is 0, and after that 1 minus 3 1 minus 1, and minus 1 plus 3 minus 1 plus 1. So friends, you know that the position a dash w greater than equals to, we get c is, we know. So my dual problem is it is a problem is maximized, so it is minimize 2w1 minus 4w2 plus 5w2 dash minus 5w3 double dash, and subject to 3w1 plus 4w2 plus w3 dash minus w3 double dash greater than equals to 2, as the problem is minimized, and w1 minus 0w2 minus 5w3 dash minus w3 double dash less than equals to 3, and w1 minus 3w2 plus w3 dash minus w3 double dash less than equals to -4, and minus w1 plus 3w2 minus w3 dash minus w3 double dash less than equals to 4. So friends, this is equation.